Hi, my name is Heather, and today we will be talking about the pH scale. There are a couple things you need to know about the pH scale. The first is three well-known numbers, 0, 7, and 14. At 0, that is where solutions are going to be at their most acidic. Now, an example of a strong acid found close to 0 is stomach acid. 7 is the perfect neutral. It is also the pH of water. And 14 is where solutions are going to be the most basic or alkaline. A good example of a strong basic solution is sodium hydroxide. 7.4 is a lesser known number on the pH scale, but 7.4 happens to be the homeostatic pH level of our blood. There are weak acids and weak bases, both of which can be found on either side of 7, meaning around 5 and 8. For example, black coffee typically has a pH of about 5, making it a weak acid, while sodium bicarbonate has a pH of about 8.3, making it a weak base. Now, this next part can be slightly confusing, so first I will explain and then we will use a visual aid. So closer to 0, those solutions are going to have the most hydrogen ions, but the least amount of hydroxide. On the flip side, the numbers closer to 14 are going to have the least hydrogen ions and the most hydroxide. So, as I said, here is that visual representation of the pH scale. As you can see, 7 is the neutral, 14 is the most basic, and 0 is the most acidic. Where it's most acidic, as I said, it will have the most hydrogen ions and the least hydroxide. At 14, it will have the least amount of hydrogen ions and the most hydroxide. Where number 7 is, they will have an equal amount of hydrogen ions and hydroxide. Now, when you move down the scale, getting closer to 0, the amount of hydrogen ions increases 10-fold for every number that you go down. That sounds confusing, but it's not as bad. You just picture whatever number hydrogen ions maybe a 6 would have, and if you go down to a 4, it would be times 10 and then times 10 again. Now when you go up the scale towards 14, you will decrease the amount of hydrogen ions by just 1/10. Fractions can be a lot more confusing, but luckily with tenths, it's not too bad. Now, I hope this video helped clear up some confusion and took away some of the mystery of the pH scale. Have a great day.